Hello everyone, welcome to this another new video. In this video, I'll be discussing about the general OOP concept or the OOP concept. I will tell what this concept is and why do we need such an object-oriented programming concept in languages like Java and all. So let's start this video. So before moving on to the main topic, please subscribe to this channel and like this video. Don't forget to press the bell icon so that you get notified whenever a new video gets uploaded. First of all, we will look into the evolution of software. So the main question comes is why we use a software. We write programs and a program serves the purpose of commanding to a computer. Now the efficiency and the usefulness of a particular program not only depends on proper use of commands, but also the programming languages it is written in. So there are basically two major types of programming languages. Those are high-level languages and low-level languages. Firstly, let's see what low-level language is. Low-level language are basically the machine languages and assembly languages. These are machine-oriented and require extensive knowledge of computer circuitry. And the next is high-level languages. High-level languages, on the other hand, offer English keywords. Like in high-level languages, you can find a few English keywords like while, for, such as. And these languages construct for sequences or selections or iterations or the use of variables, constants. These are the main features of the high-level languages. While choosing the programming languages, we should think of two main concepts that the language should serve us. Firstly, it should be close to the machine, and secondly, it should be close to the problem to be solved. That is, a language must be machine friendly. Also, the language must be user friendly. So, if we look at the low-level language concept, we can see that the low-level languages are highly machine friendly languages. While we write in mainly 0 and 1s in the machine language or assembly language, we use few keywords. In the high-level languages, serve the aspect of user friendly. That is, they are close to the programmers. Like the person who is programming can understand high-level languages much easier. Also remember, the languages like C and C++ serve both the aspects, and we can call them a middle level languages. What is that? This C and C++ are at the same time close to the machine and they are also close to the programmer. Thus, they are serving as a middle level language. We can call them as middle level languages. The next thing that we need to see is programming paradigms. What one means by this paradigm? It's basically a way of thinking or doing things. Since the invention of a computer, many programming approaches have been tried. The primary motivation in such case has been the concern to handle increasing complexity and make that reliable and maintainable. The more the complexity increased, we need to change the programming methods, we need to change our approach to programming so as to handle those complexities and maintain those high amount of data. Talking about programming paradigms, there are mainly few important paradigms which are tried while the approaches of programming was made. The first is procedural programming. Procedural programming, the approach was to tell the computer to do something. The main focus that was kept in procedural programming was on the processing and the algorithm needed to perform the desired computation. So we can say procedural programming something like decide which procedure you want and use the best algorithms you find. This is the main concept behind the procedural programming. In procedural programming, remember, the emphasis is always on doing things. So what about the data? Whenever we are giving emphasis on doing things, the emphasis on data analysis comes to the second in procedural programming. Since it's towards the first approach, so that time the data are quite low and you can focus on the algorithm to find the programming solution. The next thing that comes is modular programming. This modular programming, the main idea was to break a program into functions that can further be extended by grouping the number of functions together into a larger entity called the modules. In simple terms, we can say that modular programming is decide which module you want. That is, decide which particular set of functions you want and partition the program so that the data is hidden in the module. In modular programming, there is one small problem, that is, since many modules or functions access the same data, the way the data is stored becomes critical. Hence, arrangement of the data can't be changed without modifying all the functions that access it. Another problem that is associated with the procedural programming and modular programming is that their functions do not model the real world very well. Here, the functions do not model the exact real world kind of problems. I mean, the main emphasis is on doing things. That is, in think of a library situation, the main focus is on issuing a book or returning a book. But the main entity, that is the books, are given second class status in this approach. So next come the important programming concept, that is the object oriented programming or the OOP concept or OOP concept. To understand this object oriented concept, let's take an example. In this object-oriented concept, the object-oriented approach views a problem in terms of objects involved rather than procedures of doing it. Thus, what is that object? Object is that identifiable entity with some characteristics and behavior. It may seem confusing. Let's take an example. For example, we have an apple. Let's consider this as an object. So, as you know that as the definition says, object is an identifiable entity, hence apple, taking it as an object, it is an identifiable entity and with some characters and behaviors. So what are the characters and behaviors of an apple? You can say that its characteristics it is spherical in shape and red in color. Similarly, if you look at the behavior of a apple, then we can say that it's mostly sweet and similar behaviors. It's a fruit. But while programming using OOP approach, that is OOP approach, the characteristics of an object are represented by its data. Its behavior is represented by its function associated. Remember, the characteristics is represented by its data and its behavior is represented by its function associated. Therefore, in programming, object represent an entity that can store data and has its interface through functions. The next thing that comes in this approach is the class. What is a class? We can say that a class is a group of objects that share common properties and relations. So what is the class of an apple that we looked before? The class is apple belongs to the class of fruits. You can say that it's a kind of fruit. So the definition says a class is a group of objects. Since a group of fruits is a class, that is a number of fruits like orange, apple, and many more that share the common properties. What are the properties they share? Properties, maybe you can say they are taste, their characteristics, maybe. That's how a class is defined. So how can you say object-oriented programming in simple terms? It says decide which class and objects are needed. For example, decide you need an apple or orange or whatever. Decide which class, that is you need the fruit class and you need the object as apples or orange or guava or something like that. And then provide a full set of operations for each class. That is, what are the operations you want to perform on that class? You want to cut an apple, you want to directly eat that apple, or what are the operations you want on that class? Now implement this thing in programming. This real life concept, implement the real life concept in programming. Next, look at the basic OOP concept. This is the whatever I discussed till now is an way or is a try to make you understand the OOP concept. But in the OOP concept, there are 5 main concepts that are quite general in approach. The OOP concept or the OOP approach is made to attain the goal of overcoming the drawbacks of programming approaches or the conventional programming approaches. What are the conventional programming approaches? Those are the procedural programming and modular programming. So the OOP concept was, or the OOP approach was made just to overcome this drawbacks, just to overcome the drawbacks which those conventional programming approaches made. So the general concept of OOP are: number 1, data abstraction. Abstraction is basically a concept of simplifying real world concept into its essential elements. If you look at the definition of data abstraction, you can see that abstraction mainly refers to the act of representing essential features without including the background details or explanation. You are representing essential features but not including the background details. How? Let's look at an example. Suppose you are driving a car and you know the essential features of a car like gear handling, steering handling, or clutch or accelerator, brakes, etc. But while driving, do you ever get into the internal details of the car, like the wiring of the car, the motor workings, or how the brakes are working, or how the engine is working? You never. You simply, whenever you need to change gear or apply brakes, you simply apply those. You don't look into the internal working of the car. That is the same approach in data abstraction. What you are doing? The main thing that is happening inside is hidden from you. That is, this is abstraction where you know only the essential things to drive a car without including the background details or explanations. What is happening inside the car is hidden from you. The main concept of abstraction is that you know how to drive a car without including the background details or explanations. Hope you can understand the concept of data abstraction. The next thing that comes under the OOP concept is data encapsulation. What is encapsulation? It's a way of combining both the data and the function under a single unit. So we are combining the data and the function. We are combining the data and the function under a single unit that operate on the data. The wrapping up of data and function into a single unit is basically known as encapsulation. So to understand this concept of encapsulation, let's take an example. For example, there is a big company, and hence I can consider that it might have different departments like sales, accounts, payroll, purchase, production, etc. So each department has its own personnel that maintain its data. Suppose an employee in the production department wants to know the raw material purchased for the next month. The production department employee would not allow to himself to go through the purchase department data files. Rather, he will issue a memo or a request for the required information. Then some employee of the purchase department will go through the purchase data files and send the reply with the asked information. This practice ensures that the data is accessed accurately and that is not corrupted by outsiders. Therefore, we can say here that the department data and the department employee are encapsulated into a single entity, that is the department. Hopefully, you can understand the thing, like we are considering the department data and the department employee, which are getting encapsulated under the department entity, that is the entity known as department. The next thing that comes into the OOP concept is modularity. The modularity is the main act of partitioning a program into individual components. So why will you partition a particular program into individual components? The main reason lies just to reduce the complexity to some degree. We cannot reduce the complexity to a huge amount, but we can reduce the complexity to some degree. Whenever we are handling whenever we are handling a huge amount of data, in that case, reducing the complexity to some degree helps a lot. And the second reason why we should do modularity is it creates a number of well-defined boundaries. That is, a particular data cannot move out of a particular boundary without, say, permissions or kind of thing. So if you look at the definition of modularity, it's basically a property of a system that has been decomposed into a set of cohesive and loosely coupled modules. To understand this concept clearly, let's take an example. So you must have seen a complete sound music system. Let's assume that a program represents the music system. So this particular music system would contain many things like speakers, record players, CD players, tuners, and etc. etc. Similarly, our program can be divided into various modules with each representing a speaker, a CD player, or a cassette, like this, etc. and etc. See, each module is a complete unit in itself, yet it works in accordance with other modules in order to achieve one single aim, that is the music. Each speaker, you can consider the speakers, or you can consider the CD players, that they are a complete unit in itself. But they work with each other to attain this main goal, that is the music. Next concept that comes is the inheritance. This is one of the most important concepts used in OOP approach. Inheritance is mainly the capability of one class to inherit the capabilities or properties of the other class. Let's understand the concept. You are a human being, so you definitely have some properties of a human, that is you eat, speak, breathe, drink, etc. But these are not unique to humans. If you consider a class human, then look forward, you also inherit some properties from the class mammal. That is, you are a mammal itself. Also, if you look on a wider aspect, you are an animal itself. That is, you inherit some properties of the animals. Not all, but a few, or 1% or less than that. Mainly, you are a human, you belong to the class human. Then you inherit some properties from the class mammal. Again, the class mammal inherits some properties from the class animal. That is, you are somewhat inheriting few properties from the class animal, then the class mammal, then from the class human. Thus, you can understand how the concept of inheritance works. It's simply, in the programming approach, the concept is the exactly same. You have some base class and you have some super class. The base class inherits some properties of the super class. Like, let's say another example, say there's a car. So a car or a bus inherits some properties of the class automobile. Similarly, a class automobile inherits some properties of the class vehicles. That's how this concept of inheritance works. The concept of inheritance, I'll discuss the concept of inheritance much details while discussing the programming approach to it in Java. So let's look to the next important property. There is the fifth property and the last property, that is polymorphism. Again, I will discuss polymorphism much details while discussing about the programming approaches. But here let's note some small thing. Polymorphism is basically an ability for a message or data to be processed in more than one form. Hope you can understand what the concept of OOP is. So that's all for this video. By the way, you can follow me on Instagram at @LearnOverflow if you wish, where I post important concepts about programming, approaches, few memes, and you can learn something, I guess. So you can follow me on Instagram. Thank you for watching this video. Don't forget to like and share it with your friends, and also subscribe to my channel for regular similar videos. I'll be continuing this Java series so that you all can understand Java easily, the way I understood Java. That's the main reason. Till then, this is Shagnik signing off. Thank you.